Hi everybody! So in today's video, we're going to be taking some notes to get us ready for the first section of Module 5, which is Section 5.1. And the big idea of today is that we're actually going to be reviewing something that we already know. Our goal for today is to be able to graph a linear function given an equation, given a table, or given a situation and context. Now, today we're going to focus on what do we do if we have an equation, and we're going to review the two types of linear forms of functions that we've learned so far this year. So the first type of linear function we've learned this year is what's called slope-intercept form. Now, slope-intercept form is often remembered as y equals mx plus b. So slope-intercept form is often remembered as y equals mx plus b. Now, we could also say y equals b plus mx. The order does not matter. Either one of those equations are both called slope-intercept form. Now, the reason that we call this slope-intercept form is that in this equation, there are always two numbers, and one of the numbers in the equation tells me the slope, and the other number tells me the y-intercept. Now, in this equation, whatever number is multiplied by x is going to be the slope. This could be the first number in the equation, or it could be the second number in the equation. It's just always the number that's multiplied by x. So you'll know it's the slope if it's being multiplied by your x in your equation. The second number that we always find in this equation is the y-intercept. Now, the y-intercept is the same thing as the starting point of the graph. And in this case, it's the letter represented by the letter b. This is going to be the y-intercept, which is going to be the point 0, comma, whatever number you have for b. The same thing in this equation. The b is going to be the y-intercept, which is going to be 0, comma, whatever number you have for b. And again, we'll know that this is the y-intercept because it's being added to the x instead of multiplied. An example of a slope-intercept form of an equation would be y equals negative 2x plus 4. Now, in this unit, we're not going to remind you that you should find the slope and the y-intercept. Instead, the expectation is you should look at this equation and you should know, you know what? From this equation, I can figure out the slope and I can figure out the y-intercept. And then I can use those two pieces of information to make my graph. So my y-intercept would be 0, comma 4, because the 4 is the b in this equation, and because the y-intercept always has an x value of 0, since it's on the y-axis. The slope would be the negative 2. Now, I like to write negative 2 over 1 because I know that slope is always rise over run. Using those two pieces of information, I can graph my starting point, which is 0, comma 4. And from there, I can go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, and keep going. Using this graph, and I went backwards by going up to left 1, using this graph I can draw a nice straight line that goes through those points. Now, point-slope form is the other type of equation that we often see, and in point-slope form we write this equation a little bit differently. Usually this equation looks like this: y equals the y value plus m parentheses x minus the x value. Now, in this equation, which you normally see with numbers like this, we are able to still figure out two pieces of information. We can still figure out the slope, which in this equation is still the number being multiplied by the x. It's the number outside of the parentheses. But instead of being able to figure out the y-intercept, we can figure out a random starting point, which is why we call this point-slope form instead of y-intercept. This point is going to have a y value with whatever number is outside, and an x value with whatever's on the inside. But it's important to remember that the x is always the opposite sign. Opposite. There we go. There's an E at the end. Sign. So for example, if I was looking at this equation, the x value would actually be -1, not +1. And one of the ways we've always thought about this is that we can think about it as how do you get back to 0? So if it says +1, to get back to 0, you would need to use a -1. So from this equation, and again, we're not going to tell you what to write down, but I would suggest writing this down. You can figure out your slope, so your m, which would be -2/1, and you can figure out your starting point, which I'm going to call SP for starting point. You'll notice I'm not calling it the y-intercept because it's not going to be on the y-axis. It's going to be a random point on the graph. The starting point would be -1. Again, we're trying to get back to 0, comma 6 on the graph. So on my graph, I would go to -1, comma 6. So 1, 2, 3, 4, 5, 6. And from there, I would go down 2/1, down 2/1, down 2/1, down 2/1, and I can continue doing that for the whole graph. I can also go up 2, left 1, up 2, left 1, and I can draw my nice straight line. Now, understanding the names is really the new thing here. We've always graphed these two different types of equations, but in this chapter, it's going to be very important that you know the words that this equation is slope-intercept form and that this equation is point-slope form. So what I always remember is this. For slope-intercept form, you are always going to be able to figure out the slope and the y-intercept, which means in your ordered pair, your starting point, the x will always be 0. For point-slope form, it's going to be a slope and a random starting point. Which means it's not going to be a y-intercept on the graph. All right, let's take a look at a couple example problems just to review. Or actually, let's change topics a little bit. So the next big idea of this unit is that we can test to see whether an ordered pair is or is not a solution of an equation in a variety of ways. So the learning target here would be I can use the coordinates of a point. So in the directions, we're going to give you the coordinates of the point to determine if that is a solution to an equation, an inequality, or a system. We're going to start today with just equations, and we'll work our way up to what are called inequalities or systems of equations. So an example problem would be this. Let's say I give you this equation, and I ask you, is the point 2, -3 a solution to the equation? Now, as a reminder, because I think this is an important vocabulary word, a solution to an equation is a set of numbers that makes the equation true. So we need to figure out, is 2, -3 a set of numbers that makes this equation true? And separately, is -1, 1 a set of numbers that makes this equation true? There are two different ways for us to do this. We can do this by looking at a graph, and we can do this actually using the equation we were given. Let's start with the graph. From this equation, I know that this is slope-intercept form. So I should be able to figure out the slope and the y-intercept of the graph. The slope would be -4/1 because the -4 is what is being multiplied by the x. And the y-intercept would be the point 0, 5, because that's the number that's being added at the end. That means my starting point would be 0, 5. 1, 2, 3, 4, 5. So I'm going to start right here. And my slope would say go down 4 over 1, down 4 over 1, down 4 over 1. I could also go up 4, left 1. Now, students often ask me, do I really need to graph all those points? Can't I just graph one more? The answer is no, you really need to graph them all. It's very difficult to check if a point is a solution or not if you can't see as many points as possible. So because our goal here at the end of the problem is to check to see if these two ordered pairs are solutions, we want to have as many points as possible to check that. And then I would graph my nice straight line. Now, if I wanted to check whether the point 2, -3 was or was not a solution, I would take the ordered pair 2, -3 and find it on the graph. So 2, -3 is right here. Since that is one of the points that I graphed when I made the graph of my line, the point 2, -3 would be a solution. Now, if I wanted to check to see if the point 1, -1 is or is not a solution, I would find the point 1, -1 on the graph, which is right here. Since that point is not one of the points I graphed and the line does not go through that point on the graph, I would say this is not a solution. Another option for figuring out if these are solutions or not is to use the equation. So if I wanted to check for letter A, whether the point 2, -3 was a solution or not, I could take the 2, which is x, and take the -3, which is y, and plug them into my equation. So my equation says y equals -4x plus 5. If I plug in the -3 for the y, and I plug in the 2 for the x, I can check to see if these two sides of the equation are actually equal. Now, I'm going to simplify one side at a time. The -3 does not simplify, so I'm just going to drop it like it's hot. If I look at the -4 times 2 plus 5, I can evaluate that either by doing mental math or typing it in on my calculator. -4 times 2 is -8, plus 5 makes -3. Since -3 does actually equal -3, this point is a solution to the equation. For letter B, if I wanted to check the point -1, 1, which, by the way, I graphed on the wrong place on the graph. I am so sorry. -1, 1 is there. Same result. It's not on the line. I apologize. If I wanted to check to see if that was an ordered pair, I would take the -1 and the 1 and plug them into my equation, just like I did with the 2 and the -3. So if I plug in the 1 for y and the -1 for x, I'm now going to simplify one side at a time. Since the left side, the 1 does not simplify, I'm just going to copy it down. Since the right side would be -4 times -1, which is 4, plus 5, which is 9, and those are not the same. So I would say that this is not a solution. So again, we can check to see if we have a solution or not by looking at the graph, is the point on the line or not, and by plugging in our numbers, does it work in the equation or not? Last but not least, so we're almost done. One of the last goals of this first section is that we need to be able to write a linear equation, which means write the actual equation of the line. Now, we've been practicing this a lot. We practiced it a lot in Module 9. We practiced it a lot in our previous modules. As a reminder, you're going to want to figure out your starting point and your slope. So in this first graph, I'm going to start by finding two nice points. It looks like this is a nice point, and so is this one. There's another nice point over here. You can pick whichever two you like the best. My starting point here I'm going to use is 0, 2, my y-intercept, and my slope is going to be rise over run. So I'm going to say down 2 over 3. Using those two pieces of information, my equation would be y equals my starting y minus 2 over 3 times x. Because my starting x value is 0, I don't need to put a parentheses or adjust the starting point for the x at all. For the next one, I gave you 2 nice points to use, so I'm going to use these 2 nice points. My starting point I'm going to use is, I'm just going to show you an example that I don't use the y-intercept. So I could use 0, -1. I'm going to use 4, 0. My slope would be up 1 over 4. So my equation would be y equals 0 plus 1 over 4 parentheses x minus 4. So starting with 0, add 1 over 4, x minus 4 times, and that would be my equation. Again, this is just a review. All right, hopefully most of what you saw here was a review with the exception of the set, which is this a solution or not? That was kind of a new idea, but hopefully the rest of this was a review. Thank you guys so much for watching, and I'll see you for some practice in class tomorrow.